Hi guys, I hope you are fine. Me too, I'm fine. So guys, today we are going to look at this problem and see how we can do it. So first of all, I read the question, and the question states, if the probability density function fx is defined by, the equation is fx equals to sine x over 2, and this is now the range from 0 to pi. Then 0, all other apart from this is 0. So this one guys is now supposed to be 1. So the first question is find the mean, the second is median, and the third is mode. So the first thing guys we come and look is for the mean. And this is how we write the mean guys. It's supposed to be mu like that. This is our general equation guys. It's supposed to look like that. That is from negative infinity to infinity, x multiplied by fx dx. This one all gives us our mean. So, but now whatever we are given here is now from 0 to 5. So we are now going to look for 0 to 5. Now our limit here is from 0 to 5, like that. So we write x, and then our equation now we have sine x. That is sine x all over 2. I can now put my 2 here. Let me put it there. So guys, from there now we come and integrate that. We can use what we call integration by parts, whereby now we say that this one is supposed to be u, and this one we give it a value dv. And now, so u, we can say u is equals to x, and dv is equals to sine x. So for the differentiation of u, we can write du, that is d over dx, gives us 1. Guys, this is the short way of writing differentiation without having to write dx. For this one, v, it's actually integration of that. The integration of that, guys, actually, as we know, it's the opposite of differentiation. So this one will now be minus cos x, like that. This one, guys, you can even try again, because you can say differentiation of cos x is minus sine. Because of this minus, now it becomes the sine. So now it's supposed to be like that. So guys, we continue. According to the integration by parts, this is the equation we use. We usually use uv there minus, now we come here, we write, this is now v, and then du, like that, guys. So finally, guys, we can now come and write mu will be, we have left it out, we shall put it later. It's equals to u. This one is what I'm saying is supposed to be equal to that. So it is u, and then we have v, which is minus cos x, like that. Then minus, we now come to v, that is integral of v. Since v has a negative, this one now will change to plus. So now phi is cos x, and the du is supposed to be 1. So it now remains like that. Not forgetting, guys, we still have a half. So finally, guys, we shall have, not finally, but we continue, minus x cos x. Now this one, the integration of cos, this one there is a dx there. The integration of cos gives us sine. So this one will be plus sine x like that. So all these guys, we now put it into, we have a half here, all over 2 there. And then, now this one is from 0 to 5. So now we come and replace our limits. So when we replace 5, we are going to have, this one will now be a half. And then here we shall have negative 5. Then cos 5. This is cos pi, not 5 but pi, plus sine pi, now minus, when we place 0 here, 0 and 0, and 0 here, it will add up to 0. So finally, this is what we are now going to get. So we have already replaced. So guys, we come and now work out our problem here. So this one is going to be pi, mu, which is the mean, will be a half, and then we are going to have negative 5 there. We now come and use our calculator to calculate sin pi. For sin pi will be, that is sin 180. Sin 180 is sin 180 is equals to 0. So this one will be 0. We go to cos 180. Cos 180 is actually negative 1. So this one will have negative 1 once again, and because of that, this one now is going to change to be plus, like that. So our now mu is now given by mu. We are going to have it being equal to a half pi. So that is our solution for the mean, like that. Guys, that was our first question here. And now we go to finding the median. Now come and find the median. For the median, guys, we are going to do like this. Now look for the median. Let me write it there, median. For the median, guys, we know this one is supposed to be in the middle. And because we have, our graph is actually symmetrical. So what happens is that it is now going to be at the middle of the middle of the graph, meaning that if our range is from 0, our range now is from 0 to, that is 0 to pi, then our median, guys, is supposed now to be at the center, meaning that we'll have here, we can, for example, write 0 to m fx dx. This one now is supposed to be equal to from m to pi. So this is fx dx. So each of these guys is going to be a half. So this is a half and this is also a half. So that is the probability density function when it's integrated, because now it has been divided in two halves. That is from 0 to the middle, and from the middle to the last, which is pi. This one now is what gives us 1. So a half of it like this. This one is going to be a half, and so we are going to write this is equals to a half. Because these are two halves. This is 1/2, and this is 1/2. So if you add them together, you get 1. But now for 1 like this is a half like that, and this is also a half like that. So that now the whole situation from 0 to pi gives us 1. So guys, we pick one of them. So I can pick this one, and now look for what is our value of m. So I'll come here and write integral from m, that is the middle or the median, to pi fx. Our fx is supposed to be a half. Let me write a half there. Sine x. That is what we have. And this one now should give us a half. So guys, we work out that one. So now when we come, we will say a half. We look for the integral of sine. This one will be now cos x. And of course now it's going to be a minus. Because when you differentiate cos, you get a minus sine x. So this one is going now to be a minus. So that one, guys, from our limits is m to pi. This now gives us a half. So we equate all that to a half. So now we can come and replace. Maybe we can put the half outside, negative a half. Like that, we put it outside. And then come and put your pi there, cos pi, where there is x. And then this one now you're going to have minus cos m. And this one now is going to give us now the half now we require, like that. So coming to this now we'll have, we can actually cancel these two and these two. So we are left with, now we are left with minus cos pi plus cos m is equals to 1. So let's look for cos pi and see what we get. Cos pi we know is supposed to be, pi is supposed to be 180. So cos 180 is equals to -1. So guys, here we have -1. So -1 and negative will give us 1. So we have 1 there, plus cos m gives us 1 here. So we can bring this one this other side, so that now we have cos m equals now to 0. Because when this one comes here, it will be 1 minus 1, 0. Now we come and look for cos inverse. That's how we now get our m, cos inverse 0. So this one will give us, from the calculator, cos inverse 0 will be cos inverse 0 will give us now 90. 90 in terms of pi or radians, that one is pi over 2. So our answer, guys, is going to be now pi divided by 2. So that now, guys, this is equal to m. So that is our solution, guys, for m. And that's how you do it, guys. So guys, we continue. From there, guys, we come now and look for the mode. For the mode, let me write the word mode there. This is now Roman 3. We are supposed to have the highest point. And the highest point, guys, is supposed to be f prime x equals to 0. Like that. And then for you to get whether it's a maximum, you'll have to look for the second derivative. Like that. So that now, if the second derivative is negative, then this one is a maxima. If the second derivative is a positive, then this is a minima. And this is how, guys, it's supposed to be. You see, for the maximum, you'd have a line like it is going to go like this, something like that. And for that is for the maxima. For the minima, it's supposed to move like that. So you find all of them have a place where they have f prime x being 0. But now for you to recognize if it is a maximum or minimum, you have to do the second differentiation so that you can now be able to know whether it's maximum or minimum. So guys, we come now to our equation. And the equation is, we have a half, our fx is given by a half sine x, and so dy dx will now be equal to a half cos x. This is now, we equate it to 0, so that now we can get the point at which the graph is a maxima or minima. So now we come and now put, we say either a half is 0 or cos x is 0. So we know a half is not 0, so cos x is 0. Cos x is equals to 0, like that. And so therefore cos inverse 0 is what we are now looking for. Cos inverse 0, and this one we can use the calculator for that. That is cos, we go to cos, where is cos inverse 0 is equals to 90. So this one gives us x is equals to 90. 90, you know, it is pi over 2. So this is our point, guys. And now we need now to check whether this point is a maxima or minima. So we shall come and derive again the second derivative. That is from this one. Now we go to now d squared y all over dx squared, like that. So this one will still be a half. We differentiate that one. This one you are going to get minus a half sine x, like that. So now the sine x we are having now is pi over 2. So that is going to be, negative a half sine 90. So let's check what is sine 90, guys, and see what we get. So this is going to be sine 90. So this one gives us 1. So guys, it means now it is a negative. And so this one is now a maximum. And therefore, guys, our mode is now supposed to be this. This is now then our mode, because that is the maximum point. And you know, for the mode is where we have the maximum. And so guys, thank you so much for listening to me.